Oh, great! Oh, welcome everyone. This is our kind of research going into the crystal batteries. This is a little setup that I've put together, which is hopefully going to help in our research and uncovering how we can, benefit from this technology. What we've got here is basically it's a Jubilee clip. Sand from the beach, which is anyone can go to the local beach if they're living near one, and also got I've broken up bits of quartz crystal and put them in and mixed it all up. But in the centre here is pyrite. I thought we'd give that a try. So I've been watching some of John Hutchinson's videos, and there seems to be showing that type of material seems to be giving out a lot more voltage and also current. So I thought I'd give that a go here, and also there's a lot of information as well about these with Thomas Townsend Brown. Apparently he does quite a lot. Nikola Tesla as well has done bits and bobs of this as well, but I've not seen any of that. I can only gather that he has done because John Hutchinson, I think, got that from there. And also Marcus Reed as well has got quite an extensive library of information that he's recovered, from his own research. And but the great thing about these batteries is that that they're cheap to make, and produced properly they'll give you unlimited amounts of energy. I'm pretty sure about that from my own kind of tests. You can short them out and they'll become stronger. Also, over time they become stronger as well. I've got one here which that's made from an old torch. But this stuff here is like some kind of magnesium kind of alloy. It's like a stainless steel aluminium type of thing, but it's obviously a mixture. And on the end we've got brass here as well. And originally when I started it off, it was 0.54 of a volt. And then over time it's gone up. It's around about 0.7. So 2 years, I think. Yeah, 2 years it is now. I've had this one too. So it's 0.7 of a volt for that one. And the current's pretty good as well. It's only 1 milliamp, but if you're looking at free energy, it's going to give it you that all the time. And I think that's pretty good. On the top here, I've got some like blue tack type stuff, and what I've done is I've popped water inside there, and it's the water that seems to the electrolyte that seems to keep all this energy flowing from the anode to the cathode through the crystals, and so water seems to be this type of give that type of effect. And I was quite surprised. It's good. That's last well. So yeah. Just to give you an example of that one, I've made a couple of others as well, which this one here is weirdly enough it's from an exhibition stand, but it's kind of a magnesium type of alloy aluminium. It's a strange thing, but a strange type of material. I don't really know what it is, but I just found that it worked, from experimenting and giving it all that sort of stuff. This on the top here is brass, same as this one, the other one I showed you before, and so that seems to work very well. Inside of here they've got quartz crystal, sand, and water, and I've tried to keep it tightly wrapped so that the moisture stays inside, and I'm pretty sure that won't corrode too much. I've made some others out of energy drink cans. And the aluminium did corrode, but I don't think it. I don't know. I'm not really sure. I'll give it a bit more time. We'll find out. But yeah. So there's another one there. Oh yeah, this one here is kind of giving off just about half a volt. Yeah, I've put. There's another one I made here, and this one is as you can see is 0.52 volts when it was dry, and it's still giving that now actually. And it's just under a milliamp, sorry, yeah, on that one. And this one's the same as well. It seems to be that I cut these lengths the same, and the voltages are very similar. You know, like 0.52 volts on those. All right. What else can I show you? Let's have a little look. Okay, yeah. Right, well, so with our little creation here, which is the Jubilee clip, and the pyrite, which is in the centre, and with the sand and the quartz crystal there, you can quite clearly see that that's given off 1.13 volts, which is pretty good coming from something of that size. And what I'm finding as well with the amps is giving about 1 to 2 milliamps as you waz it over to the milliamps. Well then, you know, because it kind of creates a short and then it drops down. But you know, as you initially do it, you'll find that it's giving you around about 1 to 2 milliamps, something like that. Yeah, that's that. There are some, well, there have been some solid versions of these made, and you know, John Hutchinson, you've seen that probably, you know, if you've done your research, and so he uses, or apparently, from what I can gather, he's using a type of silicon dioxide, which is what they use for fixing exhausts. Believe it or not, sounds a bit odd, but you know, you heat it up and it creates a solid fixture which will fix. You know, if you were to do it with this pyrite here, with maybe a mixture of sand and a mixture of a quartz, then you'll find that it would all sort of weld together against the stainless steel, being the cathode, and then the anode being the whatever's going into the pyrite for this instance. Yeah, so that's interesting to note that you know that's possible to do it. I've not done it myself yet, but I'm about to. I'm going to go out and get some bits and bobs and see whether that works. Yeah, there's that. Other thing is as well. This is a lump of quartz here, just picked up from the beach again. I don't know if you can see it, but it's kind of twinkling in the light, so you can see that it has the old crystal structure to it. So what you can do with that, which is really handy to know, is you are able to measure the voltage that particular pebble is giving off. So what I'm going to do is